from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about healthy baby planets. And if I have time, we are losing our opportunity. Who wants to live on Tatooine? Lucy in the sky with nano diamonds. So many news, so little time. And of course, taking listener questions about all things in the universe, because that's what this show is about. Re-record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about the power of talking about stuff. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. Got an exciting show for you today on Space Radio where we talk about all things in the universe. If it's above the Earth's atmosphere, it's in this show's universe. Our show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus, so call 888-581-0708. You can also follow along on our live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. Hello to all the space cadets tuning in live today from Salt Lake City, Norg, Netherlands, Santa Fe, Neptune, I don't believe that one, London, and Lancaster, California, and more. We'll take questions that you send there too. Seriously, folks, I've prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls, though, I wanted to share some interesting bits of news I caught recently, and it's been a busy week. It has been a very busy week in space, which is not surprising because space is very large. Lots of opportunities for things to happen, but something was just announced today that I think is just so cool, so lovely, of where it's cool analysis, cool science, cool result, baby planets. Like, we talk all the time about exoplanets and planets outside the solar system and rogue planets that don't even belong to a system. What about newborn planets? Can we catch in the act the formation of a solar system itself? The answer is yes, of course we can, because we're really, really smart astronomers and we're good at our job. And one thing, what we're looking for is an astronomical term here that I'm going to toss out at you called a protoplanetary disk. Protoplanetary disk is a newborn star, just getting going, only a few million years old, which is basically an infant as far as stars go, surrounded by a disk of material of gas and dust and heavier elements that has compressed in the form of a disk, but has not yet congealed into planets. And then the process of planetary formation isn't fully understood, but the general picture is that little bits glue together to form bigger bits, and over time the planets form, carve gaps out of that disk, and then eventually the entire disk either dissipates, gets thrown out into the outermost regions of that newborn system, or get accreted onto the planets, and the planets become very, very big, like gas giants. And we can see this process happen. It is so cool. Even though this process takes millions or tens of millions of years to occur, we can observe so many stars in our neighborhood in the galaxy that we can catch by random chance some of this process happening before our very eyes. In one case, a star affectionately known as HD 163296 is home to three newborn planets forming around this 4 million year old star, and we see it through the gaps they leave in that protoplanetary disk. So you have to pay attention to the notes that nature isn't playing if you want to understand what's going on. These three planets are projected to be gas giants. We don't actually see the planets themselves, of course, they're way too small, but we see their effect on their environment, and specifically through the motion of carbon monoxide. As the planets move around in their disk, they stir up the carbon monoxide that's just laced through there, and the carbon monoxide gives a very specific signal, and we can see the gaps, we can see the motion of that gas, run it through some computer simulation, do some fancy modeling, and estimate the size and locations of the planets that are causing those disturbances, we see 3 Jupiter-class gas giant planets around this very young star. And this is not an isolated case. This is not the only place where we've seen planets being born. This is an industry within the astronomical community, is finding planets in the process of forming, so we can unlock our full understanding of how that process works. That's the latest and greatest. There's tons of other news. I might get to it, but if not, but it is time to have a conversation. And I've got a caller who we have on the line today. It is who?
Oh.
There you are.
Hello.
How's it going? Thanks for calling Space Radio. You've got some intense music there in the background. Do you mind turning that down?
Oh, yeah, I'll turn that down right now.
I appreciate it.
Yeah, I only got some space music.
That's cool.
Hey,
I like it. You're setting the mood. It's cool. So who
yeah,
are
yeah.
you?
I got a question about magnetars.
You got a question about magnetars. Where are you from, though?
Lancaster.
Nice. So what's your question about magnetars?
The accretion disk surrounding a magnetar is a dense magnetic field, billions of times stronger than what we're normally used to. Could they possibly form dilithium crystals?
That is a great question. So dilithium crystals, this is a funny name, isn't it? Because this comes from Star Trek, right? And
yes.
Lithium is an element on the periodic table. It's the 3rd element. I argue it's the element that nobody cares about, but that's just me.
Could that possibly incorporate dark matter with that intense magnetic field?
Right. Good question. So I got to put you on mute just because of that loud background noise. Dilithium is an element, or lithium is an element. Dilithium is not an element. Lithium doesn't bond with itself the same way other elements can bond with themselves. So we can have helium bonding with itself. We can have nitrogen bonding with itself. Lithium isn't going to play that same game. And it's not going to form crystals just because of the way its atomic structure is. It doesn't form crystals in that way, especially with itself. That said, the environment around neutron stars are some of the most exotic places in the universe. I might even argue more exotic than around black holes. You're talking about neutron stars. If you're not familiar with this, neutron stars are crazy, crazy places. Neutron stars are locations where you take the mass of a few suns, cram it into a ball the size of a neighborhood, set it spinning at tens of thousands of revolutions per minute, so faster than your kitchen blender, and voila, you have essentially a city-sized nuclear core of an atom, atomic nuclear core, spinning with a few charges that creates the absolute strongest magnetic fields known to humanity. These magnetic fields, and the strongest ones, are literally 1 trillion times stronger than the Earth's magnetic field. That's not even an exaggeration. And sometimes I exaggerate and just come up with a large number. I am not making up this number. I really do mean 1 trillion with a T. Take that, Sagan, with your billions. I'm coming out here with the trillions. And the material flowing onto the neutron star, onto that collapsed high-density core, can swirl around, form beams of light that act like a lighthouse, these jets of radiation that pierce through space by light years. And this is how we actually see these crazy, crazy magnetars and neutron stars. Magnetars themselves are just a kind of neutron star. They're the most highly magnetized neutron star, the most extreme ones. We think magnetars are the youngest neutron stars. The first formed, the newborn neutron star is at first highly, highly magnetized. Then over time, it slows down, loses energy, loses its incredibly strong magnetic fields. As far as we know, getting to your other question, as far as we know, The activity around neutron stars is not related to dark matter. Dark matter itself, the most dominant component of matter in the universe, we don't fully understand what dark matter is made of for sure. Whatever it is, it doesn't seem to be highly clustered. It doesn't seem to form dense balls the same way that normal matter does. So a neutron star isn't necessarily going to attract a lot of extra dark matter. It's not going to have a lot of extra interactions with dark matter. It's going to do its own crazy thing, which, you know what, is good enough for me. Thank you so much for that excellent question. That was a really fun topic to get into neutron stars and possible relationship to dark matter. All these cool topics that in words and jargon phrases that you hear about in science or science fiction or science reporting. That's what I'm here for. To untangle all of it. Your personal astrotherapist. You can call 888-581-0708 to join the conversation. And this is Space Radio. I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/pmsutter to learn how you can support the show. It really is your contributions that keep this show going. I'll see you after the break. Welcome back, everyone. I'm Paul Sutter. This is Space Radio. I've got some Space Cadet questions ready to go, but remember, you can join the conversation by calling 888-581-0708 or by following the live streams on Twitch and YouTube. Go to spaceradioshow.com for the links. I had a question thrown at me, and you're going to see why that's a very clever pun, thrown at me at the very, very beginning of the show from SAHM, asking about if humans, like, let's pretend humans are able to colonize the solar system. So we've got cities on Mars, in the clouds of Venus, in the moons of Jupiter. We're all over the place. We've infested the solar system appropriately. How do we do sports? And he was asking this in a silly way, but it's actually a really fun question of, the rules we're used to of mechanics and motion and air resistance and the effects of gravity are so rooted to our experiences on Earth, our evolutionary heritage on Earth. We are creatures of the Earth. You put us in a different environment, our bodies are going to change. They literally change. We see this with astronauts. And all of our expectations of the way objects move is going to change. Let's just take Mars. Let's just take Mars, for example. Number one, Mars has barely any air. 1% the pressure of Earth's atmosphere. Right now, it's causing some pretty nasty dust storms on Mars, which is posing a challenge to our missions there. But for the most part, you can basically ignore it, which means if you throw a ball, it's not going to have any air resistance. It's not going to have any air resistance, and it will follow a different trajectory than it would on the Earth, simply because of the lack of air. This is something interesting you can watch. If you look at the old footage of the astronauts walking around on the moon, they kick up moon dust. Pay attention to the way that the moon dust leaves the back of their boot, arcs up into the air, and falls back down. It is a perfect parabola. A parabola is a mathematical shape of a thrown projectile in perfect vacuum. You can see that perfect little mathematical parabola. It's like mathematics brought to life. No effects of air resistance whatsoever. Same thing on Mars. You throw a ball, it's going to behave unexpectedly. You start running on Mars. Mars has slightly lower gravity. Not slightly, it's like, 1/3, 40%, something like that of the Earth's gravity. That's pretty low. And so if you're running, you're jogging down the field or the track, or, wherever your sport is going to take place, you go to pivot, you go to turn, you're not going to turn the way you expect. Because in order to make a turn at speed, you need to dig your foot in the ground, stop your forward momentum, push off the ground, and send you into a new direction. That's actually a very complex set of changes of momentum, of exchanges of forces and energies, and we're used to the Earth being reliable when it comes to gravity. Of if I push off with my foot, I will get a certain push back from the Earth that will enable me to change direction. And that's like built in, because as I learn to walk, as we all learn to walk, when we're like 1 and 2 years old, we learn that response to the Earth's gravity. Then you change that, and it's super weird. You go to pivot, you're not going to pivot because Mars can't push back on you the same way the Earth can. You look at that, again, look at astronaut footage on the moon, which is like 11% Earth's gravity. Look how they walk. They basically skip. They do this really, really dorky skip, hoppy kind of thing that you would look ridiculous doing on the Earth. And it's not because they're wearing really bulky, awkward suits. It's because in 11% of the Earth's gravity, the movement of the bodies is different. Walking doesn't quite make sense in 11% gravity. Running is straight out when it comes to 11% gravity. You're just not going to run. The expectation you need, for the length of your legs, you need gravity to pull you back at a certain rate so that you can maintain contact with the ground, or you do it at the right pace. That's not going to happen. So you have to adopt this dorky looking, skippy, hoppy, Easter bunny vaguely thing in order to have efficient locomotion in low gravity environments. Same thing on Mars. Same thing on Europa. The only other planet where you're going to get something approaching Earth gravity is Venus. Venus is suffocating under a giant, thick atmosphere of poisonous gases. So probably not a lot of sports are going to happen on the surface of Venus because it's hot enough to melt lead. Let alone footballs and soccer balls and baseballs. It's not the best place to put up your soccer pitch or your baseball diamond or whatever. Other planets, you're always going to have to deal with weaker gravity. This is a serious challenge for future space missions. Because wherever we go, unless we set up artificial gravity environments by, say, spinning space stations, wherever, if we want to land on a surface, that surface is always going to have less gravity than the Earth. And that is a challenge for movement. It's a challenge for physiology. It's a challenge for life. And so that silly question, SAHM, actually leads to a very, very serious discussion. And I like nothing better than turning silly questions into serious discussions and serious questions into silly discussions. Speaking of a serious question, we had another question from Constellation Pegasus up here asking about current opinion on space being pixelated or continuous. We hear a lot about quantum mechanics. We hear a lot about the fundamental discretization of energy levels and momentum, of the fundamental quantum discreteness happening at the sub-microscopic level. And there's a natural question. Is space and time pixelated, discrete, or is it space-time smooth and continuous? Our picture from general relativity of the nature of space-time, is it smooth and continuous? Our picture from quantum mechanics is that it's a roiling, boiling, frothy mix. These two are incompatible. Some attempts to reconcile these two pictures of fundamental space-time say that space-time itself is discrete, that space and time come in little, tiny, tiny chunks. That sounds kind of intriguing. There's mathematics that explore this idea, and they haven't really come up with any viable theories of nature that we can test against experiments. So is nature at the most fundamental levels discretized, chopped up into tiny bits? I don't know. I'm going to be first to tell you I don't know. There's no evidence to suggest there is. And so we don't need to think there is until we get some solid theories, we get some solid evidence to make us believe that. Thank you for all the amazing questions today, both call-in and the Space Cadets online. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. So I was going to talk about the power of conferences, but instead, I want to talk about what's happening on Mars. So we know Mars has experienced a massive dust storm, the largest, most powerful, deepest dust storm we've ever recorded. This dust storm is basically turning day into night across a big chunk of the planet, and probably soon the entire planet. We have probes down there that rely on solar power. So you can imagine if you block out the sun and your little rover, like the Opportunity rover that depends on sun for power, isn't gonna like that. So the Opportunity rover is already in low power mode. It's already shut off communications, already trying to conserve power. The worry is that without sufficient power, its heaters won't operate. And, Mars right now, it's like -20 below zero. I know -20 means below zero, but I wanted to emphasize that it's 20 below zero on the surface of Mars, which is a little bit chilly. And if certain components aren't heated enough, especially its batteries, it can't bring itself back to life. This is how we already lost one of our rovers a few years ago. This little guy has been trucking for something like 14 years on the planet. This may be the end. It may not be the end. This is something we're all watching carefully. Hopes and prayers out to our little mechanical friend on the red planet facing this incredibly powerful dust storm. And before I go, I want to advertise a little something. If you live in the Central Ohio area, or if you would be willing to travel to the Central Ohio area, mark your calendars for Friday, July 13th. I'm going to be down at the John Glenn Astronomy Park, one of the darkest spots in Ohio. We are going to have a cosmic cookout. That's right. We're going to eat some grub. I'm going to talk about science. Then we're going to mosey on over to that dark sky park. There's going to be telescopes. There's going to be games for kids. I can't promise that part, but there will be science knowledge, and I'm going to guide you through the sky. I'm going to tell you some cool stories. We're going to share this beautiful, gorgeous, dark sky park. We're going to connect with nature, not on like a spiritual level, but on a scientific level. Either way, it's going to be a great time, and we're going to have food. There better be cheese. I'm talking to the organizers at WCBE. There better be copious amounts of cheese for both me and you to consume. Save the date right now. More details will come later. For the Cosmic Cookout, that's Friday, July 13th. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter. This show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is brought to you by you. Visit patreon.com/pmsutter to learn how you can keep this show on the air. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. You can also follow the live streams, all the other Space Cadets on Twitch and YouTube. Go to spaceradioshow.com for the links. You can also follow me directly on all social media channels at Paul Matt Sutter. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. What a ride. That show was like a roller coaster. Man, we went all over the place today. We talked about dilithium crystals. We talked about dark matter. We talked about Marsball. What's your favorite sport in space? What do you guys think? Space cadets, what do you guys think would be the easiest sport to translate to another planet? I know very, very little about sports, so I want your opinion to create my opinion. I'll just parrot whatever you guys say, whatever you guys come up with now. And then later in the future, when I'm in a deep intellectual conversation, I'll just say whatever you guys say. What sport do you think? What do you think, Greg? What sport would translate best to lower gravity and no air? Billiards, rugby. Greg's got nothing. Useless as usual. Frisbee. Frisbee needs air. Frisbee needs air to stabilize itself. Quidditch is not a real... Well, actually, in low gravity, Quidditch might become a thing. Weightlifting. Yes! Getting huge on the red planet. High jump. I like high jump. We could do Mars jump. By the way, guys, what should I call this episode? Man, we covered so many topics. Give me a good title for the show. Dartboard. But you need the air on the little fins for your little darts to stabilize it. Hacky sack. Who plays hacky sack? Powerball would work. It's not technically a sport. Skydiving. But then you couldn't get there because it's vacuum, so you wouldn't feel anything. As I'm packing up the show.
Yeah, you can't go anywhere yet.
Oh, I need to record promos.
Show specific this Saturday and Cosmic
Cookout. Okay, 30 seconds each.
Each.
You guys get to watch me record promos. How would you play football on Mars? We are answering the deep, deep questions, mysteries of the universe on Space Radio, 2 p.m. Saturday here on WCBE 90.5 FM. Is that good? Yeah. You're not thrilled. Do one more?
That whole gist was great, but identify yourself
Oh.
and the show, and you said everything.
Okay.
But stretch it out a little more. That was only about 15 seconds.
Oh, really?
Yeah.
Could you play football on Mars? These are just some of the amazingly deep, universal existential questions that we're answering on Space Radio. I'm Paul Sutter, and you can listen to the answer at 2 p.m. Saturday here on WCBE 90.5 FM. That worked. Now, Cosmic Cookout. Join Dr. Paul Sutter, who is me. This is 15 seconds. It says read time 15. So I'm doing what the paper says. Join Dr. Paul Sutter, who is myself, and I am an astrophysicist and host of Space Radio here on WCB 90.5 for an amazing fundraising event at the John Glenn Astronomy Park on Friday, July 13th. Save the date for this amazing Cosmic Cookout. I'll do one more. Join Dr. Paul Sutter, who is myself, and I am an astrophysicist and host of Space Radio. Join Dr. Paul Sutter, who is me, and I am an astrophysicist and host of Space Radio, because I'm going down to the John Glenn Astronomy Park on Friday, July 13th for a WCBE fundraising event. We're going to talk about science. We're going to look at stars. It's going to be awesome at this first ever Cosmic Cookout. There it is.
There it is.
Space sports in Dusty Rovers.
Yeah, Space Force.
Space sports, Spaceball. Spaceball. Siren Modern Dance, advocating for modern dance. I like it. By the way, live streamers, if you're not familiar with Siren Modern Dance, you need to go check them out. They're based in New York. They do some very amazing productions. And they're good friends of mine. Oh, yeah. We got to leave this up. Still waiting for a cool... I like Spaceballs.
Sports.
Maybe it's Space Sports. Spaceball is classic, callback. Some,
Like space sports.
Space Sports.
Space sports.
Is that Space Ports?
Space sports.
Space is ports.
Space sports.
Space Spachaports.
Space sports.
Spaceballs 2, The Search for More Money. Next time, call it the Cosmic Tailgate Hangout. But it's not before like a Marsball game.
Space sports.
Okay, once I said the word Spaceball, the chat, that's all they can talk about now.
Uh-huh. That's been done. That's a movie.
Yeah, maybe Spaceports. Oh, I'm just now catching up to the Twitch comments. I gotta find a way. Because I get so many questions to pin the questions and then I can answer more. Because what happens is I find a question and I start answering it and it's like 4 minutes later and this chat has gone by. And so chat, I'm working on a way. I'm trying to think of a way where I can flag questions, where I can answer more questions in a show. Because I think that might be more fun. I'm trying to think of a way to do that.
Expand to an hour.
Greg says expand to an hour. We're working on that. I've got 2 microphones. All right. Thank you, Space Cadets. I'll see you next week.